Ladies and gentlemen, welcome back. This episode we're going to revert some of the changes we made to the stations, and we're also going to first remove this. It should be right. Yep. And we're going to figure out what the best way for handling the whole add and remove train thing is going to be. So first I want to remove the memory from. This is actually fine. It's not going to. It should be good enough. And I've also decided I'm going to keep the top lane free, and I'll put a pack station here. This is for me as a player, because obviously when I need to add trains, this is where I'll come to, right? So I'll have a station to just go to at any time that I need to. Okay. Now this is the edge detector, which we don't need anymore. Instead, we want to go directly from this. Yep, directly from this in here, which means we are trading places once again. I think this is fine. Let's see. Item comes in here. It comes in here if it's allowed by this thing. There you go. Similar change here. Get rid of the edge detector. But this thing still needs to be connected here. I don't think it'll look much better in this. Fix the wire. Whoops. Yeah. Okay. Next up. So just to be clear, this should essentially be correct. Yep, it is. And we're going to turn off this guy so that our trains, doesn't matter. I want my trains to stay here. This is just an in-between solution. They're going to the other station. Once they come back here, once they come back to the train yard, they'll actually stay in the train yard. Or at least that's what they should do. So now I have two options. I can either as I did before, so first I need a edge detector, falling rising edge detector. Actually, no. So here's the issue. The plan was, or the new plan was to use a memory where every station, as the demand rises, would add demand, or as the demand falls, would remove demand, and so would the trains down here. And every dispatch, they would also remove one of the run from the counter. The problem is that just because a chain is served doesn't mean that the demand will fall, right? Because the chests are being resupplied at the same time. And if that resupply is fast enough, it can actually keep up with the train, and we will never get into a position where the station can actually serve fewer trains. The problem with that is that the trains that are being dispatched still count down the demand counter. So we get into a position where the stations never add more demand, but the trains always remove demand, leaving us with zero eventually, even though trains should still be moving. I'm thinking that I want to solve this all in one spot, which is going to be here. The way I want to do it, let's see, way there, remove the grain wire here. Oh, okay. Now, think about this. What do I need to do? So an easy option, and maybe I should forget about centralizing the demand control, would be to say, okay, if a train departs, but yeah, the demand hasn't changed, we add one train. Then I would need to revert that again. I would have to go back to the it's probably even easier than anything I was planning to do. over here. So instead of deleting this, we'll add more function, which is so first I'm going to have to move this downward, I think. We'll see. Yeah, you're going to read the signal. And if the signal throws a red, yeah, no. We're going to read the train. But we need to make sure that T is not needed anywhere. And it actually seems to be here. It is, yeah, okay, so different. Do we use I already anywhere? Don't think we did. Okay. How far does the green go? Not all the way. Up to here. It's not good enough. That's the global. Okay. Okay, so first of all, how would this have to look? When L remains unchanged, but a train leaves, send a pulse of 1L. Yeah, essentially, yes. And this can't be using this system, at least not without skipping the rising edge detector. So yeah, we do need a second slot down there. So how do I move this one down? I really don't wanna. Can I just... Let's just try that, I guess. See how it works out. And it would have to cover this anyway. So it wouldn't cover more than one line down there, even if I moved it down. Because I still have to cover this guy up here. I think I'm actually best served just leaving this here. This is a little bit annoying, like this doesn't fit nicely, but I'll see what I can do. So we need the green wire from here down here. And we also need this wire down here. And we need this wire down here as well. Also, we can actually just we'll see. Yeah, because I don't need to make this computation. That's not necessary. I don't need that computation. I only need to know what item, which I do here. I can actually take that directly from this combinator. If so, I need a falling edge detector. Okay. T. No, I. If I is output we'll see if that works. Ah, there we go. So if I falls, but L does not fall, so but L Um, yeah, I actually think this has to be a falling edge detector. No, damn it, the system doesn't work either, because right. So trainee leaves Trainyard, discounts one from the system, drives to the station. Station loses one demand, also discounts from the system, regains one, we're still down one. So we specifically have to compare to before the train came in. Yeah, okay, so we need a memory that knows what the L was before a train came in. And if it's the same when the train leaves, send the signal, send one, well, one demand. It's a bit more complex than what I was planning on here. um, so I put this guy here and connect you directly to here and you to here. Okay. Next, we move everything up one. Okay. How do I? Yep. And you can move over there. Okay. Moving up. And one more. So now I have more space. Looks a little bit cleaner too. Well, some of it at least. There's not quite as many wires crisscrossing. It's not that nice over here. It's much preferable. This can't stay here anyway because of the belts, but think about that another time. Yeah, I have plenty of space upwards if I need any. Which way are the belts moving? I can make some fit, no worries. I could do this too if I needed to. Also no problem. But yeah. Where are we? Here. So what was it? There was some leftover tests that I don't need anymore. Not sure why that was still a thing. Must have forgotten to turn that off or something. Okay, let's see. I need the info of before a train came. What was my last? What was my demand? If the state from before the train arrives to just when the train leaves remains the same, then I need to send a +1. If the demand actually sinks while the train is there, and then the train leaves, that's fine. What happens if... No, 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 no. Wait. If the train comes in, demand sinks 1. Here is the problem. Ideally, the system would function in such a way that simply stations only add demand as they need demand, and train yards only remove demand as they fulfill the demand. The problem is that there are situations in which stations also lose demand, such as somebody messing with the chests or stations being removed, right? But I think the first step is indeed to make sure that instead of tracking when demand is being removed, stations can only actually add demand, and then I need some special circuitry to gonna under what circumstances does a station lose trains it can serve for a loading station? That's when stuff is being removed from the chest. Then it probably can't serve as many trains anymore. Okay. This is the unloading. Okay. Rises when inventory is increased. Falls when inventory is decreased. Trainyard. Ay, 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 ay. A trainyard can only remove demand dispatch when a train is dispatched. So in almost all cases, train yard station demand will only rise unless a train comes in, gets loaded, and the inventory isn't shows up as fast as the train is loaded. But that's taken care of by the dispatch countdown by the train yard, right? So in almost all cases, that the train yard takes care of the falling demand from the station. The only time when that's not enough is when you as the player or somebody as the player or bidder or whatever explosions, burn, fire, whatever destroys inventory in the station. In that case, the station still needs to be able to communicate that falling demand. So I can't not use a falling and rising edge detector. The station has to be able to communicate its whether or not its demand rises or falls. So the +1 to demand can only be sent if the demand does not at all fall during the time that a train is being loaded. So what we're going to do is we're going to check if a train is present. Move you up for a second here. If a train is present, train was I is not 0. While the train is present, I'm just going to use black here because whatever. As long as a train is present, keep track of the demand. And if the demand falls, so for that we can use a falling edge detector, which should be, I think, this, right? Yes, okay. So if during this time Let's whoopsies. This one too many. There. While a train is present, keep track of demand. Which has the demand? That's the red. That's good. That lets me let L through. Input. Move that right on through. And if the demand does fall, then we can this is uncomfortable. So what I want to do is, ideally I would simply say, okay, if the demand falls, while a train is present, if the demand falls, send a signal, which is going to be the control signal here. And this tells me that I do not need to send +1 to demand. So this goes into memory. Black equals 1. Output 1 black. Oopsies. Here. Let's move you up here, I guess. So what do we have? If a train is present, pass through L, and as long as there is no falling edge of L, actually here we have a slight issue. As soon as the train leaves, I'm going to have a falling edge here, because as soon as there's no train, it won't pass the L anymore, which satisfies the condition of a falling edge. And that's the moment we set this as well. But that's actually probably useful to me, because I need to reset this latch between trains anyway, but I need to figure out a way to use like the final tick of this latch. If a train is present and slight change in plans, I think. So if a train is present, And we see what is this? This is the global. No, this is the item. Not sure we'll need that. If a train is present, which gives me a 1. And we have one equal to, give me an L. If a train is present and we have a fall in L, then you can set a latch, set latch. Could probably actually turn this combinator into a latch. One greater than 2. So as soon as a train arrives, this thing will set itself. But when we get... Okay, this is getting kind of complicated here. Maybe it is easier to actually still keep this as an AND gate instead. I was thinking I could use a train coming in as the set command for a latch. And I could, except I would need to actually, make this a rising edge detector. If I is bigger than 0, send a 1. This is an I and an I. So what happens? Train arrives, sets the latch. If during this time our L falls, we release the latch, but if it does not fall, the latch stays empowered, which tells me that if I currently have no train and the latch is empowered, I need to send a demand of +1 to the global network. And at the same time, I also need to release the latch. I also need to release the latch if the train leaves. Wait, do I? So, I only have two possible outcomes. The train leaves without having reset the latch, without having reduced the demand, in which case the latch does not get released by this part down here, but it will get released when it sends the impulse, the one-tick impulse to increase demand. The other outcome is the train leaves, but during its time in the station, there was a drop in demand in the station, in which case the thing was released early. In that case, I do need to make sure that no tick for added demand is sent. That's actually the difficult part. So let's just put that on real quick. Outcomes 1. Train leaves with no demand during its processing. 2. Train leaves with demand drop. Sing. This demands that I send one tick, one demand. And reset latch. Do not send demand and to reset latch. These are the two outcomes I have. The first one is easy. I can basically use the action of the tick itself. I can basically use the action of the latch being reset to send the tick. But this one is harder. No, wait. Yeah. So if the train leaves and it has not dropped demand, this guy over here is going to be set when the train leaves. I can use this as a second AND gate. this is set and a train leaves. Got a falling edge detector here for the train. And now we also need a rising edge detector. Whoops. There you go. So if the train I'm confused. Wait just a second. So this is the train arrives, it sets the latch. If no drop in demand is detected, the latch is not released. If the train leaves and the one equal 2, if the train leaves and the latch is still set, gotta make sure that I don't get any contamination here. Yeah, this doesn't work. I don't want to connect this directly here. I want to connect only this one. If the train leaves and the latch is still set, send 1L. This goes to where to? Basically in here, I think, or something. Input in here to the red wire. There. Problem. This will actually be a good test. Let's see what happens. So, train has arrived. I mean, you should be set at this time unless the demand fell for some reason. I'm not sure what this means. Okay, let's give this another go. Okay, input signal. Here we have an input. Yes. Output. Wait, what? What the fuck? That's off. There's something very strange going on here. What's causing that huge drop? Okay, so first of all, I want to delete this guy here, just real quick. So that's strange AF. Um, so first of all, this guy can only allow positive numbers. As makes sense, there can be no negative demand. So we're going to fix that real quick. Where are we? Greater than 0. That should do it. Yeah, that should do it. It's not an arithmetic, so it's not going to like clock on itself. It's simply going to preserve what we have. So I'm going to disallow transmission for a second and reallow it. That means that we now see a normal number here. Indeed we do. Still normal. And we'll do the same over here to keep the trains moving. We should still see normal numbers. No, we don't. The L is broken. This thing over here is pretty broke. That's fine, we'll just delete the crap out of this. So you guys get to move up. I think that was hey. And this needs to change again. This one over here. Uh, was it, I think, I plus 0, 0. That should be the right change. We'll see if there's any troubles anywhere. They'll pop up. And you are called load. That is correct. And we're going to delete the memory again. One, two. So we currently have only the unloading station call demand. Why not the loading station? Oh, cause they're riding into the same. Are they? Yeah. So the loading station does not need the bit shifting. Instead it writes directly here. There you go. And now we need to delete the memory one more time. See if that solves it. I might have missed some more issues somewhere. That should be unloading. And 15. That's one too many. Might have been served by this guy over here. Hmm. Hmm. Still happens. Loading 65K. What's going on here? Why is that happening? This part. Let's check if our so the loading station has no pitch shifting in it. Not sure of that. Still weird. That is correct now. But I'm not sure if that's only correct because the train left. Could have been the reason why. We'll see. So what happened here? L65K, why? Am what is this? Not important. $14. That's passed on to the filter. This filters out the L. Puts out 14. Feeds that over here. I have an idea. No. Um, so far so good. Outputting 14. That is as it should be. What's happening over here? It's also the right way around, so there's no cross-feeding here. I don't understand why the numbers are so weird. I think 4 was enough. It annoys me that this doesn't work. So we're empty right now. If I go to this one, this is the bit shift. Go to this one. Disallow transmission, okay. Send info, it says 12. What? Oh, because 2 trains left, okay. At least that makes sense. 2 trains left, we'd go from 14 to 12, okay. That much is okay. This is 16. This is 16. Now, can lift that here, we need that for the circuit later. If I turn this back on, enable you, what do we get? U30. I think I know what's happening here. So we can't actually allow this to exist as long as we're working with the memory. It seems to break the memory pretty much. This should have basically broken it again. And it does. So we're basically back to the whole there's one major reason why I'm thinking that I might not want any kind of tick signals from stations to handle all of that local. It's because adding and removing stations isn't as fluid then. Like if I delete the falling edge detector, it's not going to detect when a station goes away, basically, right? And I think that's going to be the reason why I will end up not going with any kind of rising or falling edge detector in stations. I think I need to undo that and again just send the state to the global and then as I planned handle everything in the train yard itself rather than the stations. So let's figure that out. And that's actually fine because it's only in the train yard that I need the information. I don't need it in the train yards. So in that case, let's just remove this sheet. Let's remove the falling edge detector, the edge detector. You fit in here and you fit in there. Right. Get rid of this, move this back up here, and connect you to the global. No. Okay. So, oh, we have, of course, now our memory is going insane. Yep. Currently, this is what it's supposed to be. Now we just have to figure out a way to actually turn that into something useful. And the way I figure that will happen is oops, something along these lines. So you are a global network. Whoops. Okay, you can go all the way down to the bottom. So these guys down here are merely interrupters if I don't want trains to leave the station. I turn this thing off. All the trains stop getting their dispatch signals. Just like this. No more dispatch signal. And I'm going to actually have this go this way. Hmm? Why are you no work? What the hell? Hello? What? Oh, of course. U and L. Given you have 14 U's, you should be showing them. Why aren't you showing them? There you go. Now it's working. Okay. So the core problem, just to recap, the core problem that I want to solve is that when I have a lot of trains and I keep track of which train is what kind, right? So I have counters here that tell me, okay, so I have 2 trains here. Let's say I only need 1 train of these empty trains. The first one leaves, and suddenly this one turns from E2 into E1. Therefore, because I need 1 train and 1 equals 1, this train also leaves. Now I could of course solve that by oh, this is, I'm just running in circles here. Try to solve one problem, introduces another problem, trying to solve that problem, introduces another problem. Just sending me around in a circle. The easiest way to handle stations is to have them permanently communicate a state. That works fine, but that introduces trouble down here. Namely, too many trains being released. I can stop that by not allowing trains to automatically count themselves, but that's not really an option. Dang it. What do I do? This is very annoying. Wouldn't that be an option if I count the number of trains? First of all, you guys can stop reading the train. Okay. If I count the number of trains assigned and detract that from the... There might be an option. Think about this. So, station wants a train. Info goes to the Trainyard. Trainyard releases a train, but because the demand hasn't gone down, I get a chain reaction of additional trains being released. Now, getting that demand down based on the memory and stuff down here, it's all really complex. I can do it, but it's gonna be a chore. And it's probably gonna be prone to like user errors and stuff. If I instead, if a train gets released, if I discount that via the read train count from the L, or from the down here from the demand, that communicates a lower demand to the station. The question is only if that is fast enough to stop more trains from being released. And to ensure that, I could just add a timer in here that waits like, I don't know, a second or what, to release the next train. That might be actually enough. Okay. So, new plan number fucking 5 or what? Use train count over here to modulate the demand the station sends. That way I shouldn't have to work with any memory over here at all. And since the stopped train count reads not just the train that's currently there, but all trains that want to go here, that should actually serve quite well. It's annoying that I hadn't thought of this before, but hey, haven't worked with this feature before. I haven't seen what other people do with it either. I might have been a lot faster here if I checked out what other people do and learned from their mistakes or whatever, or their method of doing things. But that's going to be in the next episode. Thank you for watching.